Okay, so point we must direct up a rough plane at 30 degrees. So that's 30 degrees. And particle with speed of 5 meters per second. So it's 5 meters per second. Mass mg. So let's put some forces on here. That'd be mg. Any object will always have an r. Non-contact force, and it's a rough plane, so there's going to be friction coming back this way, nothing else going up. Coefficient of friction is 0.2, so mu equals 0.2. It's moving, so I'm going to have limiting friction, so I'm going to have F lim equals mu r. Going to need to know what r is at some stage. Also going to need to find friction. Calculate distance before it travels up here, so I've got to work out the distance. I'm going to call that x before it comes to rest, so that'll be 0 meters per second at the top there. This is going to be an energy question, so I'm going to have total initial energy equals total final energy. Let's just do that. So that's going to be kinetic energy plus potential energy, or gravitational potential energy, kinetic energy plus potential energy. But that's not strictly true. If there's no external forces, that is true. But there is an external force. There's no motor here or anything, but there is the friction. And so I'm going to have to do some work done against the friction, and I've got to decide which side to go put it on. And total initial energy, that initial energy is some of it's going to turn into the final energy, but some of it will have to be used up. So that's going to have to be split. So I'm going to also get down here work done against the friction, and that'll be a force. That'll be the force times by the distance. In this case, it's x. Kinetic energy is a half mv squared. Gravitational potential energy is mgh. I want those formulas down at least somewhere. I suppose technically that should be u squared because it's initial energy. I am going to need to know what F is, so I might as well carry on working out what this is. I need to find out what R equals, so that means I'm going to resolve perpendicularly, and that will give me R equals mg. Well, one thing I don't like about my diagram, I haven't put in this angle here. That's 30 degrees. So that'll be mg, and that'll be this bit here, cos 30. And that is 8.48704. So now I know that F lim equals mu, which is 0.2, times by that, which equals 1.6974 times, well, I should have an m there, shouldn't it? That's worked out g cos 30 and the m, so that'll be F lim will be that. So we've got, it's a half m. The initial velocity is 5, so we times 5 squared, plus gravitation will take that to be 0, equals kinetic energy at the end. It comes instantaneously to rest, so nothing, plus m times by g times by h, which is our vertical component, so of the height, which is that bit there. The angle is 30 degrees, so that'll be x sine 30. That's what x sine 30 plus the work done against friction. So the work done, we just worked out, was mu times, or 0.2 times r. R is 8.48 m. So we just worked out what friction is, so that's 1.6974 m times by the distance, which is x. And that gives me, or the m's cancel out, which is good, because they don't tell me the mass, they normally will cancel out. And that'll give me half of 25, which is 12.5, equals, both have got x going in here, so the x times by 9.8 times sine 30 will be 4.9 plus 1.6974. So that'll give me x equals 12.5 divided by 6.5974, which equals 1.89468, which equals 1.89 meters to 3 significant figures. Don't forget, question 2, energy type question. We're not going to use Stuva and stuff for that. It's M2, go with energy. Most important thing to remember is the work done against friction, all the work done by the motor. That's question 2 done.